So here we're actually going to do an example of the matched pairs. Before we look at that example, let me just show you what we're looking at the previous video. Just down here, I've added in that the mean difference that comes from H0 is just D0. So these are the equivalent formulas. So what that number D0, this mean difference from H0, is just referring to whatever number you have on the right hand side. Okay, that's all it refers to. So let's look at an example. A Chicago-based firm has documents that must be quickly distributed to district offices throughout the US. The firm must decide between two delivery services, UPX, United Parcel Express, and Intex, International Express, to transport its documents. In testing the delivery times of the two services, the firm sent two reports to a random sample of its district offices, with one report carried by UPX and the other report carried by Intex. Do the data below indicate a difference in mean delivery times for the two services? And use alpha equals 5% level of significance. Well, we have the time for the two different services, and they're giving us the difference here as well, suggesting this is a difference question. But why would this be a difference question? Why would we just do what we did in previous examples and solve it that way? Well, let's see. This company is sending out parcels from Chicago. It's a Chicago-based firm. And for example, Milwaukee is very close to Chicago, whereas Seattle is not very close to Chicago. So it would be unfair to try and compare UPX and Intex by giving one of the companies, say giving Intex a parcel to deliver to, well, it doesn't really matter, giving one company, say Intex, a parcel to deliver to Milwaukee, which is close by, it's not going to take that long, and comparing that to the other company, giving them a parcel to take to Seattle, which is a lot further. It'd be very unfair to do that. So the best way to actually see if the firms have the same delivery time or different delivery times on average is to actually match pairs. So you give both companies a report, a parcel, and you ask them to deliver it to exactly the same location. So it starts from the same location in Chicago and goes to the same location in, say, for example, in Seattle. And if there's a difference in the delivery time, that means it's due to the companies because you're comparing like for like. So just the general question suggests that you should be doing it as a matched pair, but also it gives you the difference of the times it takes, which also is suggesting that you should be doing this as a matched pairs question. So what is it that they want us to check? They want us to check to see if there's a difference in the delivery times, okay, in the average delivery time. So if we just look back up here, it says we want to see if the data indicate a difference in the mean delivery time. So the difference just means not equal. So what we're actually trying to do is find out if the difference, the average difference in delivery times, okay, are not equal. They're not the same. So if they're not equal, the difference will not be equal to 0. Okay, that's what not equal means. They're not equal to each other. If they were equal to each other, then the difference would be 0. But if they're not equal to each other, the difference would not be 0. And again, if we just go back up, we're going to see that then when we have a mu d is not equal to some value, it's going to be this first scenario, which is going to be a two-tail test. So to solve this, we're going to have to do a two-tail test. This will be our alternative hypothesis. Remember, we always have to stick to the conventions that we're given. And the null hypothesis, H0, is going to be that the mean difference is equal to 0. If the difference is equal to 0, the difference in delivery times is equal to 0, it means there's no difference. It means that both companies do about the same job. If the difference does not equal 0, it means one company is faster and the other company is slower. So this is going to lead, using the critical value approach, to a two-tailed test. And these questions we always do as a t-distribution, and we put 0 in the middle, and we're going to have two critical values, one here and one here, and this one's going to be minus t of alpha over 2 with n minus 1 degrees of freedom, and this one's going to be plus t of alpha over 2 with n minus 1 degrees of freedom, and the do not reject is right here, the green do not reject H0, so do not reject H0 here. And we have reject H0 coming through here, reject H0, and reject H0. The reject H0 zones, how big are they? Well, they're 5%. Their size is 5% in total. So this zone over here, again, we could do the normal distribution. But this zone over here is 2.5%. And on the other side, likewise, that's 2.5%. We could start off by working out the critical value here. So the critical value, we're just going to use t dot inverse of alpha over 2. So if this area here is 2.5%, the area to the left of this point all the way is going to be 0.975. And the degrees of freedom for this are going to be, what will they be? Well, let's see. What's the sample size? The sample size is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And remember the degrees of freedom are, let's see, n minus 1. It tells us here degrees of freedom are n minus 1 for this type of question, the matched pairs question. So if n is 10, n minus 1 is 9. So we can pop over to Excel and work this out. So which is just over here. That's going to be equal to t dot inverse 0.975, comma, degrees of freedom is 10 minus 1, which is 9, giving us a value of 2.26. So we'll go back over to here. So we can calculate this. It's going to be 2.26. Okay, so this is going to be over here minus 2.26. And this point over here is going to be plus 2.26. So what remains now is that we have to calculate the test statistic and see where it falls. So where does that fall? Well, d bar minus the difference. So let's see, the standardized test statistic is going to be d bar minus mu of d, or d0, whatever you want to put in there. And what was that divided by? That was divided by standard deviation over the square root of n. So it's going to be divided by the standard deviation. And remember, the d means differences over the square root of the sample size. Do we know any of this information? Well, we don't actually. We don't know the sample mean. We don't know the sample standard deviation. We do know that this figure in here, d0, is 0 from here, and we do know the sample size is 10, but we don't know d bar or the standard deviation. So we need to find the average of the differences and the standard deviation, the sample standard deviation of those differences. So what we can actually do is actually read these. You don't actually read all this information in right now over to the Excel spreadsheet. Let me just copy that out and go over to the spreadsheet, and let me put this information in here. Okay, very good. So we need to know the mean of the differences. Now, if you want, you can add them all up yourself, and you can divide by 10. I'm just going to go and use Excel. So the mean difference is just going to be equals average. So we're just going to work out the average here. So it's 2.7, and the standard deviation of the differences is just going to be the standard deviation, and we said we have a sample, so we're going to use this guy in here. Highlight those. There you go. Sort those values. So we've got 2.7 and say 2.91. Around there, 2.7, 2.91. So let's go back over to here. So we said that D bar, we said it was 2.7, and D0 is just whatever values in, look at the null hypothesis, whatever values on the right hand side, so that's going to be 0. It doesn't have to be, but a lot of the time it is. Then we said that the standard deviation is about 2.91, and divide that by the square root of the sample size, which is 10. Now what we can do is pop back over to Excel, get an accurate figure for that. So we can actually do the calculation here. So we can put the test statistic, and what's that going to come to? The test statistic is going to be equal to 2.7. So it's going to be 2.7 minus the mean difference, which was 0. Won't make any difference. I just put minus 0, and then we're going to divide that out by the standard deviation, which is 2.91, divided by the square root of the sample size, which is 10. See what that comes to as our test statistic. It comes to about 2.94 is our test statistic. And we already established what the critical value was. So let's quickly go back over to here. Test statistic comes to 2.94. So this equals 2.94. 2.94. So where does that fall? Test statistic is 2.94, and the 2.94 falls, let's see, somewhere over here. This is 2.26. So the conclusion is that we reject H0 and we go with the alternative hypothesis, which is suggesting that the mean difference is not the same. So that means they do not deliver on the same with the same speed, that one firm is faster and one firm seems to be slower. So this was using the critical value approach. You can also use the p-value approach, but before we move on to the p-value approach, I'll show you another way that Excel could have solved this before we get too far and we remember the numbers. The 2.26 is our critical value, and the 2.94 is our test statistic. Let's have a look what Excel can actually do for us to have calculated that. So coming into Excel again, Excel has another function, and that function we're going to find if we go into data first of all, and then move over to data analysis over here. Okay, so data analysis, and if we scroll all the way down and count 1, 2, 3, 4 up, there's a t-test paired 2 samples for means, which is exactly the matched samples or the matched pairs test. So let's have a look what that gives us. What does it ask us for? It's asking us for variable range 1. So our variable range 1, let's see. We skipped over a bit, but that's okay. Our variable range 1 is what? Our first variable range. and I didn't include the actual title UPX in there. And then variable range 2 is the data for int-x. Okay, and I didn't include labels, so I'm not going to check labels. The hypothesis mean difference is that D0 we've been talking about, which is just 0, and alpha for this question was indeed 5%. And where should we put the output? Let's put the output here. Let's hope it fits in okay. Press OK and see what we get. So we've got a whole bunch of output come through from Excel quite quickly. So you can stop and rewind the video to see how I did that. But in particular, we've got the test statistic, and the test statistic is 2.93. It's that value we got in there. So when we did it more manually, we actually had to jump through a couple of hoops to get there, and that's a very important figure. The other thing we came up with, if you remember, was the critical value of 2.26, and that gives us the critical value as there as well. Now what's important about this, if you look back at when I actually put the data in for this, it didn't ask me at any stage is this a one-tailed test or a two-tailed test. I just gave it the data, and it actually gives us the test statistic, and it gives us data assuming a one-tailed test in here, even though we didn't have a one-tailed test, and it gives us the data for a two-tailed test in here. So it actually gives us both sets of results, and you just have to say, well, I'm dealing with a two-tailed test here, so I'm going to take these results here. So not only do we get the test statistic, we get the critical value, so we can solve it very quickly that way. It actually gives us the p-value as well, so we can actually draw the same conclusion of reject H0 from this p-value. But let's go back and let's calculate the p-value manually before we look at this one here. So how are we going to calculate a p-value for this question? Well, let's have a look. So scroll down a little bit, see if we can fit it in. So we're going to use the p-value approach here. So the p-value approach. Now with the p-value approach, we need the test statistic, like that. We need the test statistic to be put on here. Test statistic is 2.94. And we need to work out the area in here, the area in the closest tail. So it's going to be Excel works to the left. So if we just do a t.dist, that's going to give us the area to the left, t.dist of 2.94. It asks us for the degrees of freedom, which are sample size minus 1, which are 9. Then we have to put 1 or true. But that's going to give us the area to the left, but we want the area to the right, so it's going to be 1 minus that. And the other thing is, in this particular case, we have a two-sample hypotheses test. A two-tailed hypotheses test. It's a two-tailed hypotheses test. And so that means this is not the p-value. We have to multiply this by 2 in this case. So we can go back over to Excel. Let's go back to Excel. Not that one. Let's go back up to our Excel here. So if we want to actually work out the p-value, we're going to have to say it's equal to 2 times, and it's going to be 1 minus t.dist. 1 minus t.dist. And the value we need to put in there is the test statistic, which is, I said it's 2.94. We can actually put in the accurate value, which is this thing in here. And then we can actually put in the degrees of freedom, which is n minus 1. And then we can put in our 1 or our true, close the parentheses, and see what we get. And indeed, we look what we get. We're getting this figure in here, which is exactly the same as this figure in here. If you want to express that as a percentage, come up here and hit the percentage key. It's around 2%. So let's see what that means to our final answer when we're using the p-value approach. So the p-value is going to be 2 times this, which is approximately equal to 2%. I think it's about 1.6%, but let's put in 2%. And what do we know? We know that if alpha is greater than or equal to the p-value, that implies we reject H0. And alpha for this question was 5%. And 5% is indeed greater than or equal to 2% or 1.6%, however accurate you want it to be, but it is greater. So that implies again that you reject H0. And it's exactly the same result as we had before. So you can see there's more than one way you can solve it. You can kind of crunch it out manually, or you can actually get Excel to do a lot of the work for you by using the data and data analysis over here, and using t-test paired to sample for means, pressing OK, putting your data into here, telling where you want the output to go, and you should practice that now.